Today, we're going to talk about the future of application development. A decade ago, when Docker started, we came into the world, we burst onto the scene, and we changed the world of application development forever. And it was a pretty exciting time. We're all in this industry because we love the constant rate of change, the constant excitement, the constant new things. Last year, large language models brought AI to everyone's attention. There was a huge change. Like AI and ML have been around for a long time, but it was a step change, a sudden excitement, explosion of creativity, explosion of new ideas and exploration, and everyone wanted to get involved. And there were two things we learned at Docker about that. One is that the whole build, share, run model and the whole Docker tooling was really important in this new AI ML world. People, wanted to still be able to ship reliably to production. The development experience was really important. All that was really, there was a lot of continuity with the decade of change. The second thing you told us was that you really wanted to get started and learn this new stuff because it's a whole new tech stack, a whole new set of things, and so many people were excited and wanted to explore and learn because this was just really, really exciting. So we got together with a bunch of our community and the people we love to work with to bring you a great get started experience. Now, you don't want me talking, you want demos, don't you? So let's, let's build with Docker. Let's welcome Harrison from LangChain, Michael from Neo4j, and Jeffrey from Ollama, and let's have a demo.
Hello, DockerCon. I am so excited this morning to build a new generative AI application. And the easiest way to get up and running with this is the Docker GenAI Stack.
Excellent. So these are the partners we've brought together. And you've got to imagine that this is the development team at a company called Recursive Inc. They build next-gen software. They're a pretty rock star dev team. I'm pretty excited to have them on board at Recursive. Now, Recursive does next-gen software, so they have a lot of customer support questions. They have a big customer support portal because people have a lot of questions about next-gen software. Building a customer support application for Recursive is what this team have decided to do. They've decided to use LLMs to build a new stack to help people answer these support questions. Recursive has a great big database of internal questions from many years about next-gen software and things. If you look closely at these questions, you might recognize them from Stack Overflow. But hey, we all copy things off Stack Overflow sometimes, don't we? So the team are going to get started. They're going to use Docker Compose because that's a great way to get started. And we've got a stack which has an Ollama model. That's the language model from Ollama. We have LangChain to hold it all together and build the application and provide observability. And then we have Neo4j providing the database for the extra data we're going to bring in. So let's go.
It all starts with a familiar command you know and love, Docker Compose Up. I'll go ahead and run that, and you can see the different components of the GenAI stack being brought up. The first component is the AI model. And for this, we're using a new tool named Ollama to download and run the popular Llama 2 model by Meta. The second component is the vector and graph database named Neo4j. And lastly, we have a Python application powered by LangChain, the orchestration layer for GenAI applications. Looks like these different components are now up and running. So I'm going to go ahead and open this up in my browser. I'm greeted with the screen where I can prompt and ask questions and chat with this model. So I'll go ahead and ask it a question. How do I summarize PDFs using LangChain? It's a bit of a trick question. It seems like the model's giving me an answer, and it's all running locally here on my Mac. Unfortunately, though, the model doesn't really seem to know what LangChain is or how to use it. So how are we going to solve this problem? For that, I'm in luck because my teammate Michael here can show us how we can augment this model with the knowledge it needs to answer the question correctly.
Thank you, Jeff. So as Justin already said, we have this large knowledge base of existing customer question and answers that we want to integrate into our application. So our second app that we are running here is the importer app, this one. That basically allows you to pick any tag that you're interested in from the knowledge base that we're using, this kind of public knowledge base for the demo. And it will import this data into the knowledge graph, into the graph database, vectorize it for the vector search, and then it's ready to be used by the GenAI application. So if you import this data into the knowledge base, it basically looks like this. So you see the purple ones are questions. The orange ones are tags that we imported here, and these are all the LangChain questions from Stack Overflow. Right? So we should be now able basically switch the mode of this model to include this information from the database, send it together with the user question to the LLM, and have the LLM generate a useful answer for us. So let's see how well this works. So I'll use the same question that Jeff just used. I just copy and paste it so I don't have to type things. And put this in here and switch to RAG enabled. So RAG stands for Retrieval Augmented Generation. That means whatever I do with the LLM is not based on the data that the LLM was trained on, but it's only using the language skills of the LLM. Completely ignores the training data and gives you basically all the context information to generate the answer as part of the prompt. Right? So and that's what we do here. We take the question from the user, turn it into vector, query the database, then from the knowledge graph, pull all the relevant context from this information and send all this text information to the LLM, which then uses that to answer this question as such. And as you can see, now it suddenly knows about LangChain. It knows about the pipe PDF loader and embeddings and vector databases. And what's especially cool is you've all seen ChatGPT make stuff up, and then it never was able to produce sources for the things that it made up. But here, because our information comes from a database, we pass along with the information also the source links. So I can basically now just open one of these source links, and you see that it goes back to the source of the question. So that becomes much more trustworthy and reproducible and verifiable in terms of answers. Right? But what's happening behind the scenes, what's happening under the hood, Harrison will show us how we can actually peek behind the corners and also look at the code to see how we operate behind the scenes.
So as Michael mentioned, this is using a technique known as RAG, Retrieval Augmented Generation, where it pulls in extra data. And so this is an example of a chain that LangChain helps orchestrate, which is basically a template to create an application in a few lines of code. And so to show exactly what's going on, I'm going to use LangSmith, which is our observability and tracing platform, to show the difference between the first chain, which didn't have RAG enabled, and the second one, which does. So if we click into this, this is the first chain that Jeff ran. And so we can see that there's two components to this chain. There's a prompt template, and then there's a call to an LLM. And so let's make this a little bit bigger so we can see exactly what's going on. If we click into the prompt, we can see that we have our inputs here. So this is the question that was asked. How do I summarize PDFs using LangChain? And there's no chat history, but this is also a conversational bot. So it enables this back and forth iteration if we want to do that. We can also see a bunch of metadata about the run. So we can see the serialized version of the chat prompt template here. And then we can also see the final thing that the chat template produces, which is these two messages, a system message and a human message. These are ways to pass inputs into the language model. And we do that exactly in the next step, where we interact with chat Ollama, which is the Llama model. We can click on the metadata field, and we can see a lot of information about the Ollama model here. So we can see the name of the model that we're using and all the parameters that are going into it, and where it's being hosted, which is locally. If we go back to the run, we can see the exact input to the model here, system and human, and then we can see the output. And this is the same thing that was generated in the UI. Let's now look to see how that compares with this other chain, the retrieval QA with sources chain. If we expand the full trace, we can see that there's more steps. There's first a retrieval step, so let's click into this. We can see that we have an input query, how do I summarize PDFs using LangChain, and then the output is now a list of documents. And so this is using Neo4j to look up the list of documents behind the scenes. If we look at the metadata, if we look at the little side panel here, we can see that this retriever is tagged with Hugging Face embeddings, which are open source embeddings, as well as the Neo4j vector store. So we can see exactly where this retrieved data is coming from. Now if we click into the chain, we can expand it to see exactly what's going into the language model. And so we can see here that we now have this system message that instructs the language model to use the following pieces of context to answer the question at the end. And then we have the documents from Stack Overflow, or not Stack Overflow, which we're using to ground the language model in our response. And here we get back the AI-assisted answer. So this is hopefully a good sneak peek as to what exactly is going on behind the scenes. We'll be doing a much deeper dive on this at 11:45 right here in this room. So I'd encourage you guys to come here and check that out if that's interesting. And with that, I'd like to thank Docker for having us, and yeah, encourage everyone to explore GenAI on Docker.
Thank you.
Thanks, that was so cool, and it was exciting just to be able to learn and do things like that. You can try this out yourself. Click on the link in the Learning Center of the latest Docker desktop, or go straight to the GitHub repo. And you can put your own data in, you can change the models, you can play around with it, you can rebuild it, you can rewrite it, you can do anything you like with it. So really, really cool. And there's a deep dive talk, 11:45, if you want to learn more, and all of the team are at their booths and can help you as well. If that inspired you to build with AI and ML, join our hackathon. We're running a hackathon for the next month. There's a hack space down here. There's online support. There's people ready to help you with all your problems. It's going to be really exciting. Let's build some cool things. If this has inspired you, you can build something like this, or there's many, many other things you can build with Docker, AI, ML, and this exciting world of GenAI. Now, we love to work with our customers and understand how Docker is helping them build things more effectively, faster, and build amazing stuff. It's always so cool spending time with them. We spend a lot of time talking to customers, working with them. I'm sure you've heard of this customer. I'm sure you've assembled their products. Let's learn about how they assemble their own applications with Docker and AI. So welcome, Karen. Great to see you.
Great to see you. Hello, everybody. How are we doing today at DockerCon? Woo! Slightly more people than yesterday. Maybe. All right. Glad to be here, see you in person, and speak about our ML platform. But before we do that, who are we? We are Inca Group. We are the retail arm of IKEA, which means we are the ones that are running the different stores and pickup points that you've been to, our planning studios. And we are essentially a 42 billion revenue company and headquartered in Netherlands. We are over 177,000 coworkers across these different stores and different formats that we have. And we get about 3.8 billion in terms of hits to IKEA.com. And we operate in about 31 different countries. Apart from that, physically, we are in about 482 locations, both as large format stores, small format stores, planning studios, pickup points, and so on. Apart from that, we also have a shopping center business across 14 countries where we manage shopping malls, which have IKEA stores in them. We also believe in creating better homes, and our products and our range reflects that. And you will see, for example, a product like a Beacon, which reduces 95% of tap water usage when it's used as a nozzle. We're also a value-driven company, and over 80% of our coworkers believe in our values, live our values. We also have sustainability and circularity at our core, and the last years we've refurbished and sold about 32 million products, giving them a second lease of life. And apart from that, we're also quite diversity focused. At our leadership levels, we have a 50-50 gender balance between male and female. Apart from that, we're also big on corporate social responsibility. We always try to help the refugees by making them employable, as well as react to situations like, for example, the Ukraine war or the Morocco earthquake. Apart from that, we now head back to the impact of AI at IKEA. I mean, we are like any other retail company, right? I mean, we have the same sort of systems, same sort of problems, and we also have AI in our strategy. So what that implies is that we have been investing to build a nice data and analytics organization, quite comprehensive, which is embedded with product teams that build digital products for the many people. However, the idea of these teams was that they're small, they're self-reliant, and develop with speed. But what has happened is that we've run into different issues where it is becoming more and more of a challenge to deploy a model from idea. I mean, as it is, we have a 20% idea to deployment rate, but with these challenges, we started to drop even further. So what are these challenges, essentially? The infrastructure footprint. I mean, with the growing number of teams and growing number of sort of AI use cases or AI ideas, we started to run into challenges with having the right compute available, right infrastructure available, right? When we were having our servers, we used to have one model per server. Big model, less compute. Small model, too much compute. And did we say governance yet? I mean, that's another whole ball game. Now, coming to development. Before, when we started out, it was my machine is my compute. I need a Python, a Jupyter notebook, and I'm good. But now with GenAI and stuff that you already heard, it starts to become more and more complex with the compute that is required. We need to have a GPU. We need to have multi-tenancy so that multiple people can work together on the same compute. And that is challenging to do as it is today. And then, of course, we've also had a huge transformation in how models are deployed, right? I mean, first of all, they're isolated from the software layer, and then they could be deployed in Canary, Blue, Green, and so on, which essentially means that we have challenges with scalability when the model gets suddenly a whole lot of data coming in. Portability, which means the model needs to be present across different environments and on the edge and so on. And the isolation piece, because we need to be able to separate it from the software layer and yet maintain the same efficiency of like less than 5 milliseconds, for instance, for live models, which run on IKEA.com, for instance. Basically, all of this coming together, making it a sort of a complex situation with one big impact. A, ideas not moving, but more importantly, we take more and more sort of time to deploy models. And we have not even spoken about the data problems that come, right? That's for another talk. Now, moving ahead, right? I mean, we heard the challenge. What was the solution, right? I mean, it was not all dark. That's where I say Docker entered the game and started to help us. I mean, there was a time when we were, for example, getting requests for development environments, and what we were essentially doing is allocating servers from the data center at times, with people sharing them, or people would use VMs in the cloud, which is pretty standard, and start to share them. But this had to change. And this started to change when we started to containerize and basically use Docker to give container as a data science environment for people to experiment. Let's take an example of a recommendation algorithm, right? I mean, we are now helping the teams with these different Dockers in which they experiment the different recommendation algorithms that might be required, right? Call them the AI training lab. And after this vast experimentation, they end up with what's called as trained models. These are with high accuracy, performing to the business case, and then these then come to us as model registries where we learn what's the metadata, the data versioning, the model versioning, and everything surrounding the model that needs to be deployed. Now we combine this model with Seldon Core, and then what we start to do is we deploy as requested. I mean, it can be a blue-green deployment, canary deployment, or even deployment in the edge. Right. So moving ahead. So this was the first step of our transformation, right? I mean, you heard, for example, how Docker is helping containerize development environments that allows us to, deliver better models at a faster pace. And then you heard how, for example, Docker, when combined with Seldon Core, is able to deliver a deployment platform which allows us to deploy at scale. Now, when we combine that with something like a Prometheus, we start to get the monitoring. Monitoring not just for the models, the model performance, but also the platform's performance, right? And it starts to become important because we need to have the model available 99.6% of the time, for instance. And when we combine that with, for example, Seldon Alibi, we start to measure drifts and so on, adversarials, outliers, which is essential to look at a future of automated retraining pipelines. And all of this comes together with IKEA's engineering. And we will deep dive into this whole platform in a talk at 10:45 today. But that is essentially how the whole platform is built. And that brings us to one most important thing. What did we gain from doing all of these changes? I think the biggest gain has been that we are now 10 times faster from idea to production. I mean, we still have a 20% conversion rate in terms of idea to production, but at least we are faster in doing that, right? I mean, we've gone from being 100+ days to being less than 10 days to have a deployable model. And most importantly, we are also able to platform at scale. And the second thing, and then for us as a platform team, the biggest thing is how do your users actually look at your platform and what do they use it for? And we were -10 for a long time, which means that our users were not really recommending our platform to other users or other data scientists. That has changed over the last 2 years. And now we're doing almost +18% and have more than 100 people actively using the platform today and deploying models, observing models, and so on. That's my time. Thank you so much. We're sticking around for the rest of the day as well, so happy to meet and connect with all of you. Have a nice day, and I give it back to Justin.
Thanks so much. It's so great to hear our customers having success with Docker. It's what makes it so satisfying to work at Docker. It's why we come in every day to help you, and it makes us so happy to see you being successful. Behind these last two demos, and the demos you saw earlier and the Karen's work, we saw a lot of Docker trusted content being used to build secure, efficient applications. And Brittany's going to come on and talk more about the work we're doing with secure and trusted content for AI ML applications, because this has been the real foundation of the success of many of your applications and the customers. So welcome, Brittany.
Thank you.